S. All right, so the left-hand side dealt with. Right-hand side. Does the M's aren't changing. We'll just cover that. The question is, do the accelerations change? I got a sleepy no. Pardon?
I say yes.
We got an awake yes.
Yes.
We have two awake yeses. I got a nod in the back. What changes?
The acceleration.
How does it change?
Because there's friction and it's going this way, yeah. It would be slowing down.
It's starting at rest. The initial velocity is 0, so it's not going to slow down. Joey? Yeah, it would be 0. We're looking, it's starting at rest. The minimum value so that they do not move. This isn't just stopping for a moment. This is, we sit them there and they just stay. This is back to 0 again.
Equilibrium. Right.
Yes, it is equilibrium. Substitution phase, we have a new equation. Oh, I put F, that should be Fs. Oh. What is the formula for static friction?
F. No. Mu y.
All right, so generically mu y, static friction is going to be less than or equal to mu sy, but we're at an extreme, excuse me, we are trying to find that minimum value of mu s. I know 0, it's going to move, so we're trying to find sort of that extreme. So Fs equals mu sy. We want to know when the maximum static friction is equal to this, so that's the substitution we're doing. So I have M6G sine theta minus the tension minus mu sy is equal to 0. I have y equals M6G cosine theta and tension minus M3G. Yep, equals 0. We know theta, we know g, we know the two masses. We don't know tension, don't know normal force.
Hold on. We can take the second equal. Oh, we already said equal to it. But well,
We don't know mu.
you were stepping ahead.
So our unknowns.
Here's my thinking. I'm thinking we make a really big equation. Okay.
Okay.
So we take. Well, first we have to make sure that Ft equals positive M3G. Right.
Okay.
And so now we're gonna take Y, which is equal to that, and Ft, which is equal to that, and plug them all into that big old equation.
I think that's what you're saying.
That's exactly what I said. And we can, oh, I think now it's time for numbers.
Okay.
So,
This was 50 point.
58.8. Or
No, times sine.
Times sine.
This
Yeah.
0.92
50.92.
minus not 30. 29.4 minus mu s times 29.4 equals 0.
And so then we're gonna do. And then we did the fifth, on the first or the second, technically problem that we did 50.92 minus 29.4, that equals 21.52. So then we're gonna take that to the other side, or no, we already have it on the other side, and divide by 29.4.
All right, so the minimum value of my static coefficient is 21.52 over 29.4. Now, if you presented this as your answer, I would mark off for it, because one fraction bar per answer, and the decimal point counts as a fraction bar, so I've got, in essence, 3 fraction bars. So, if you want to take the lazy route, multiply top and bottom by 100, so over 2940, so that would be a legitimate answer. Or, you got a calculator, use it. So around, 0.7.
Yeah, 0.73. So you would want us to make it a decimal?
No, don't give me decimals with a fraction part. This, I would take off for that answer.
Oh, okay. Got it, okay.
Because the decimal point represents, in essence, a mixed number.
I see.
I'm confused about how setting friction equal to mu sub s y gives us the minimum. Wouldn't that give us the maximum?
If mu sub s were 5,000, do you think it would slide?
No.
All right, so whatever mu s we're gonna find, it's gonna be a minimum. So that can't be a maximum value of mu s, because I can make my friction even larger and it's still not gonna slide. So if we're looking for that value, that sort of that breaking point, that point at which just a little bit off of that potentially gets the whole thing moving. So since we're at that cutting edge, we're at that breaking point, that's why we're dealing with a maximum. That's why the static friction is maximum static friction. So we tried to find the minimum value of mu s so that the maximum static friction just barely keeps it in place.
Oh, okay.
So, would you have to have units on this?
Pardon?
Units?
No, not from mu. Mu is just a number. Other questions? There are a whole bunch of problems that all look very similar to this. The next step, though, we will get into breaking up something other than weight. And that will get into centripetal motion. Let's see, you got test tomorrow.
I thought the test was Thursday, or someone changed it.
It's Wednesday.
Oh,
I at one point had it down for today, but I changed it to Wednesday so that you got the full-time block.
well, that's right, that's right, I remember reading
So on the 28th, 920, you have test 1A, 928. We'll do the homework quiz on 4, and we'll just say master set 4, 5 application due, no, concept. And then,
Master set 4 and 5 together.
yeah, I've got it broken up. I've got 4 and 5 concept and 4 and 5 application.
Is it the same document?
Yeah, 2 different documents. Unless I'm confusing this with a different class, but I'm pretty sure that's the way I have it split, yeah. And then,
When's the master set?
10-5, homework quiz 5, master set, 4-5 application.
Are we in chapter 5 right now?
Yeah, 4 and 5 get blurred together, so that's why I combined the master sets. All right, so here's the deal. I would rather do, no, you haven't had test 1A yet. We'll discuss it on Thursday. We'll keep this as is, and if we change it, we'll change it on Thursday.
Is, master set being the same day Chris Forrest did? 28?
Yes. Let me hand some stuff back. I was grading the projectile motion labs, and for the most part, I'm pleased. I've had classes where nobody gets it, which is disturbing.